For more than 4 decades, the Tomahawk cruise missile has been one of America's most recognizable weapons of precision strike. First introduced during the Cold War, the missile has evolved considerably over the years, adapting to new technologies, new missions, and increasingly complex battlefields. Now, the United States Navy is preparing to take that evolution a step further, not by replacing the Tomahawk, but by dramatically increasing the number of missiles it can produce. In August 2026, the U.S. Navy awarded Raytheon, an RTX business, a 7-year contract valued at approximately $22.9 billion. The objective is to accelerate production to more than 1,000 Tomahawk missiles per year, a dramatic increase from the roughly 60 missiles produced annually today. The scale of this investment provides an important insight into how the United States expects future high-intensity conflicts to unfold. The issue is not simply acquiring a more advanced missile. It is ensuring that the United States has enough precision weapons to sustain combat operations over an extended period. In a major conflict, particularly against a technologically sophisticated opponent, the initial stockpile of missiles could be rapidly depleted. Ships and submarines may fire dozens or even hundreds of weapons, while additional missiles are simultaneously required for other theaters and for the replenishment of allied forces. Industrial capacity, therefore, becomes an increasingly important component of military power. The Tomahawk is particularly valuable because it provides the Navy with long-range precision strike without requiring an aircraft or a surface warship to approach the target itself. The missile is approximately 20 feet long, about 21 inches in diameter, and has a wingspan of roughly 8.5 feet. Powered by a small turbofan engine, it travels at subsonic speed while flying a programmed route, including very low-altitude flight, intended to make detection more difficult. Its greatest advantage, however, is not speed. It is the combination of range, precision, flexibility, and increasingly sophisticated guidance and communication systems. Modern Tomahawks use a combination of navigation technologies, including inertial navigation, GPS, and terrain and scene matching. The Block 4 tactical Tomahawk also introduced two-way satellite communications, giving commanders the ability to receive information from the missile and, under appropriate circumstances, modify its mission after launch. This flexibility is particularly valuable in a modern battlefield where targets can move, intelligence can change, and the operational situation can evolve rapidly. The latest Block 5 generation continues that development. Improvements to navigation and communications increase the missile's effectiveness, while the Block VA Maritime Strike Tomahawk adds another important capability, the ability to engage maritime targets. That development is particularly significant for a Navy preparing to operate in environments where enemy surface forces, aircraft, and missile systems can threaten American ships from considerable distances. But the Tomahawk is no longer exclusively a Navy story. The U.S. Army has incorporated the missile into its Mid-Range Capability, or MRC system, commonly known as Typhon. Rather than launching the Tomahawk from a ship or submarine, Typhon places long-range missiles on mobile ground-based launchers. This gives the Army a capability that can reach well beyond traditional land-based artillery and allows it to contribute directly to the long-range fires mission. This creates an increasingly important connection between American land and maritime forces.
So this is the first time the mid-range capability, or the Typhon, has been on a Japanese base. It's the second time it's been in Japan, but it's the first time it's been on a partner base here in the region to allow us to increase our interoperability and increase our deterrent effect.
My favorite portion of Exercise Resolute Dragon has been seeing the development of the soldiers. Them employing Typhon for the first time to the country of Japan is a huge step forward, not only for them, but for the United States Army and its alliance with the government of Japan.
The Typhon system can deploy both SM-6 and Tomahawk cruise missiles, strengthening the U.S. and allied forces' ability to strike back and counter threats in the region.
In a future conflict, an adversary may have to contend simultaneously with Tomahawks launched from Navy destroyers, submarines operating beneath the surface, and Army mobile missile batteries positioned on land. These systems do not necessarily have to operate independently. They can form part of a broader network of sensors, command systems, and long-range weapons designed to distribute American firepower across a much larger battle space. That concept is particularly relevant to the Indo-Pacific, where enormous distances and heavily contested waters make it increasingly difficult for conventional forces to operate close to an opponent. The Tomahawk fits naturally into that concept because it can be launched from several different platforms and can perform different missions. For the Navy, it remains a critical long-range land attack weapon, while the maritime strike variant gives it a growing role in anti-surface warfare. For the Army, its integration into Typhon provides another layer of long-range precision fires that can be deployed from land. The enormous increase in production is therefore about much more than simply replenishing America's missile inventory. It is an attempt to ensure that the United States can sustain a modern precision fire campaign rather than relying on a limited stockpile of highly sophisticated weapons. Recent conflicts have demonstrated that advanced missiles can be consumed at a surprisingly rapid rate. At the same time, the United States is expected to maintain its own readiness while continuing to support allies and partners. That makes manufacturing capacity, supply chains, and the ability to rapidly replace expended weapons increasingly important elements of national security. In that sense, the Tomahawk represents an interesting combination of old and new military thinking. The basic concept dates back to the Cold War, but the weapon has continuously evolved with new guidance systems, communications, targeting capabilities, and mission profiles. And now, the United States wants to produce those missiles on an entirely different scale. More than 1,000 Tomahawks every year would give the Navy a much deeper magazine, while also supporting the broader network of American long-range fires. It reflects a growing recognition that in a future major power conflict, technological superiority alone may not be enough. The United States will also need the industrial capacity to sustain that superiority. The Tomahawk, once a Cold War cruise missile, is therefore becoming part of something much larger, a distributed American strike architecture linking ships, submarines, aircraft, and ground forces across vast distances. And in the wars of the future, the ability to deliver the first salvo will certainly matter, but the ability to continue delivering precision fires long after that first salvo has been fired could ultimately matter even more.
10, 9, 8, 7, 6, 4, 3, 2, 1, launch.